But hi everyone. So I was just going to talk a little bit about testing in MicroPython. So how the code itself is tested, and what tests we have, and how they run, and also how coverage testing works as part of that. So we want to make sure that all the lines of code we have written are tested, and not all of them are, because it's quite hard to test everything, but we try our best. So the test suite itself is in the tests directory. Okay, there's a few unclear files there, but we have a lot of subdirectories. So yeah, there's about so there's about 1,200 tests. So each individual file, Python file here, is a test.
So and that's
let's see if we go up. There's a lot. The basic ones here. So each one is named by sort of what it tests. So say string format or unary operations on sets. And the trick, well, from the very beginning when I started writing MicroPython, I wanted to make it as close to normal Python as possible. So the idea was to, because I was starting from scratch, to really try and get it as close as possible, because there were many sort of nuances of the way normal Python works. The first thing I did was make sure that the bytecode that MicroPython emitted was equivalent to CPython's bytecode. So I had a bunch of test suites that would run some scripts. MicroPython would generate bytecode, do the same thing with CPython to generate bytecode, and make sure the bytecode was identical. And that way I could sort of be confident that it was going to work correctly as well, as long as the bytecodes were implemented correctly. So this was the really initial test suite that I made. And then over time, so that got quite good, we got quite close to CPython. But then the tests were replaced with functionality tests of actual scripts and not bytecode. So that's what you see today, is that it's just a Python script that will do something, test a particular feature. And instead of checking bytecode versus bytecode, it just checks the output versus the output. So that's obviously more higher level equivalence between the two, because we don't really care that the bytecode's the same as long as it behaves the same. Yeah. And nowadays, our bytecode's diverged a bit from CPython, and because it's moved on, it's also added more bytecodes and things anyway. So, and it doesn't need to be, it doesn't have to have any correspondence at all. So now it's just a bunch of tests like this. So if we have a look at like set the unary operations on sets, wow, this is pretty simple. It's just tests that that bool works for empty set, it should be false, it should be true for a non-empty set, that length should tell you what's in a set, and you shouldn't be able to hash a set because it's mutable. So basically you just run this under normal Python and it gives some output. So and then you run it under MicroPython, and you see that the output is the same. So it's really easy to write a test. You don't even have to know what it's supposed to do. If you can write a script that runs under normal Python, then you've written a test, because you just run it under both and make sure it works. So it's good to have CPython as this reference thing, so you consider CPython to be the truth, and then that's sort of the thing that checks MicroPython as well as it can. So yeah, I mean, it's pretty good, because a lot of other projects you might work on, if you wanted to write a unit test, you've got to write the test and then work out what it's supposed to do and write the output of the test. But in MicroPython, you just skip all that. You skip the second stage. You just write anything to test really. So it's quite good. So you can run the tests on any port. So you can run it on Unix port of MicroPython, or on a PyBoard or ESP or anything, and they should pass. The test suite tries to configure itself so that it doesn't try to do features that are not supported on a given board. And so if you bring up a new board or with MicroPython, or a new platform or system, you can run the test suite, and hopefully it'll pinpoint the areas where you've maybe got something wrong. And so you should try and get full coverage of the test suite and full execution. Because there's a lot of, apart from functionality tests, there's also some stress tests which they're trying to add more as well. So for example, for recursion, just to check that if you recurse a function infinitely, so this just calls foo itself forever until you get a runtime error. So that's actually something that's not easy to make it work, because you've got to make sure you've got stat checking on and everything. So if you've ported MicroPython to someone new, you really should run these tests, and they will really show you if you've done it correctly. There's other things for like garbage collection, testing, and so on. So it's quite sophisticated. And the biggest thing is, so you can, if you run the tests, it just, so it goes through and runs them all and tells you if they passed or failed. Some of them will be skipped. So there's quite a few there, and we'll run them all to completion. But one of the biggest things is with the Unix port of MicroPython is we could do coverage testing, which is when you run the whole test suite with a special version of MicroPython where the compiler has inserted some accounting information into the code to tell when every line and branch was executed. And then you can make sure that every piece of code you've written has been tested. Because there's really no point in writing code if it's not tested and it's not executed by a test. So here we can see that everything passed. There were some things that were skipped because some features were not enabled. But if you do, so this coverage testing, so it runs the same kind of thing, but just with a different build. It takes a long time. But to see the output is very interesting. So it's just processing the results. I ran this earlier, the coverage testing. Okay, so we get some statistics here, but what's more interesting? Hang on. What's more interesting is
we have been talking about it.
The coverage report that you can generate. So this shows you every single file, how much has been executed. You can see there's a lot of red, but these are library things that we don't consider because they're external third-party components that we assume have tested, so we don't test those so well. But for example, the py directory where it's the core interpreter, so that has 99.2% coverage in lines. So everything there is, well, there are some things that, this is only one line missing here, but it shows loads. It's only got 5 lines. But you can see that most things are covered to 100%. Now we can find something that's not covered, say, okay, let's try this one here. And it shows you, so here it's like, this plus means that both conditions of this branch were taken, the positive and the negative, the true and the false. So it also checks branches. Because sometimes a branch might always be true or false and you never tested any other condition. So that's also coverage. But you can see that this line was never executed. But that's actually an error because the next line was executed. So there's no way that line can be executed if that wasn't. So there must be an error there with the coverage. Let's find a different one. Let's look in the parser. This one's probably... So you can see here some branches that haven't been executed properly. So here, that one's a bit hard to see because it's a macro. Inside this macro there's actually 2 conditions. So it's got, there's 3 conditions. So it's got 3 little bits here. 2 of the conditions had both their positive and negative been tested, but branch 0 here was always positive. So we've got to write a test. We've got to look inside here and see which branch wasn't tested and write a test that fails that if we wanted to get coverage there. But yeah, it's a lot of work to do all that. So branch coverage is not as good as line coverage, but it's close. Yeah. So there's something not executed. No, that's false. Okay. Here's another error.
Branch coverage is still above just about 90%.
In here, yeah, it's still pretty good.
Really high, like
90, only 90.2, but yeah. So it's actually quite hard to find something in this directory that's uncovered and it's not an error in the coverage. So here, what's that in?
We'll look into that for next year.
This is also an error because these lines are executed, but it tells me that that's not.
Just look for something I've submitted, it won't have any tests.
Well, no, that's the STM stuff's not tested. There's less testing in this. the module stuff, like for example, it's really hard to test
I'm not quite understand your question. Do you mean
SSL
we
stuff.
want something? Would
So
be
there's a lot of red
interested in
here.
Stuff that we can create that's our own creation.
Yeah. So here, this is testing like when you read on an SSL socket and I don't know, you overread or underread. So, but to test SSL sockets, you have to set up a SSL connection, and that has to be different every time because of the way that the connection is connected. So you can't really make test suites for that. But, well, you can't make. It's not easy to make test suites for
You mean
that.
being more specific or actually
The other
being
things that
more
are hard to
creative
test are
with the
errors.
actual machine?
Yeah, some of these, most of these here could eventually be fixed. But anyway, this is just the overview. So you can generate this data yourself just by running MicroPython and lines. We try and make sure that any new code that goes in is covered straight away, so that you don't have to go back and try and cover things later on. But yeah, anyway, that's what I was going to say. Free to talk to me later if you like.
Okay.
But
Very cool. So how much effort is put into improving that? Like
a lot of effort went into getting a lot of effort went into getting 99% in this directory, which is 15,000 lines of code, and it's not. Some things are easy to do. Like if you just ran a few scripts, you probably get 60% coverage to start with. But to get that last few lines, like there's probably 127 lines left. And I've tried a lot to get them, and some of them are just really, really hard.
Yeah.
I can't do it.
You imagine be like edge case kind of scenarios where you're really having to use some specific solution to get it to work.
Oh, this one, that one's annoying. That one's. See, some of them are just like, I mean, threading. Threading is really hard to cover. So here's an error when you're requiring a lock. Yeah. So I don't know how you make that actually occur. So a lot of the cases, it's errors that I have that are not tested. But yeah, there's one where you're resizing a dictionary and you get to the maximum limit of the primes in the table that we have for resizing. So there's actually been a test added for that not too long ago. So there's here is a list of primes that are used to resize the dictionary to sort of double 1 times 1.5 every time in size. And to actually get to that last prime and then hit this line here, there's a specific test just for that.
Wow.
And writing a test for that takes like half an hour or something. So,
Oh my god.
you know, if there's 100 lines left to cover and each line might take up to an hour to actually get a test for, there's a lot of work just to get that last little 0.1%. So yeah, it's been a lot of work.
Yeah, I can imagine.
But yeah, it's
Is that
actually
with a
fun.
glazed look on your face?
But it's like a computer game, you know, you've got to get the next, it's like, you know, trying to
Yeah.
score high, so you're like, how can
Yeah.
I hit this line, let's write a test. And then, you know, you gradually eat away at that coverage. So it's kind of fun.
And it seems like some of the ones that are left are like old nemesis. So-
Yeah, I've been through all of them
Yeah.
to try and find the ones that are doable, and the ones that are left are the ones that are really hard.
So one area we could maybe make some improvements in is like for port coverage. So I've been accumulating hardware, as you know.
Yeah.
So it would probably be a good thing to like set up like a continuous integration server and test it on those various ports. It's not even thinking about it. Is that being done?
Well, this
or-
is just done on the Unix port, yeah.
Yeah.
So there's nothing really. There are tests that run on PyBoard, but they don't really. It's hard to do coverage in an embedded system because, like, the executable doubles or triples in size, and it doesn't even fit on the board anymore. So how do you run it? But it would be great to have more tests, hardware integration tests. Yeah. But it's a real, because then you got to have something set up, or at least something to set up, and a consistent way to build this tester. And yeah, I mean, it's definitely doable, but it's more different kind of work. Yeah.
Let's think about it.
All right.
Sounds like an interesting project.
Yeah,
Yeah,
just 'cause
more.
I need more.
The real advantage to trying to run them on hardware though is to test the other peripheral functions that aren't on Unix. that means you've also got to have something to exercise their peripherals. It's not just
You've got to have a test system with bits and stuff.
usually you've got something physical plugged in and out to read inputs and write outputs and all the rest. So
Yeah.
it ends up being another exponential amount of work to try and test more and more peripherals. Yes, you essentially do,
Yeah.
and document how that's built and test how that's built.
Make sure the jig stays the same,
Yeah.
and then
And then how do you test your test system?
Yeah, exactly.
Yeah.
right. Make it self-test. CRC check or something.
So, Damien, will there ever be a time where you'll say it's good enough?
I think 99% was my sort of mental barrier, and like 99. Yeah, I think 99%. It's pretty good. Now I'd love to
Yeah.
I'd love to
I
do
think-
more, but
I think we're all involved.
if I could get 100% in the core, there are some things that are actually impossible.
Oh.
Like this one here, I think is because it's needed to silence the compiler warning, so it never actually gets there, but it's counted as coverage. So,
Can I just comment that line out?
but then it has a compiler warning for building. So there's going to be a few things like that which are really hard, and I don't know why this one's branch coverage as well. But we can also see that there were some errors in the coverage tool itself, not picking up certain lines. Maybe that's because I ran it on a stale set of binaries, but yeah, I'm not sure. But
No, that's great.
cool. Right.
Impressive.
Yeah, it's something that really promotes sort of acceptance of the quality of the software then too, especially when you're looking at using it professionally. Having that kind of framework in place just elevates the whole project to a really high level.
Yeah.
It's very impressive.
It sets the standard for it. 100%.
And it's also good for if you want to change something and then you're not scared, because if you change even something subtle, it can break like lots of tests, and you're like, oh okay. So yeah, you're doing something.
Yeah.
It's good. It's sort of a safety harness in a way.
Yeah.
But it would be good to get it on the ports as well in some kind of fashion. But simulators could help there.
Yeah.
Is it just really, I mean, forget about the extended hardware, is it just a memory issue? Really?
Doing coverage.
Like if there was enough room for the...
Because to
big
do the
binaries?
when it runs under coverage, it's got to write to files to say that this line was executed n times.
Right.
So there's a lot of it's not only the executable that's large, but it's got to have a file system to be able to write all the data to.
Right.
So to
So you have
execute
to
it
be
on
a
a
fast
target.
file system too, right?
No, it could be slow. It just would take a while to run. It just needs to be big enough.
Like SD, onboard SD?
Yeah, it could be an SD card, but you'd have to set up the coverage. Well, I'm not actually sure how it writes the files, which part of the code does that. So you'd have to augment the code with the knowledge of the file system,
Yeah.
so that it knows how to where to even write the data. Yeah, no, it's definitely doable. But yeah, I think it's good work.
Someone's got to do it.
Stop looking at me.
You're floating all your projects. Come on.
That's right. Okay. All right, I'll stop now.
Thanks, Damien. That's awesome.
Thanks, Damien.
Thank you.
Yeah.